Hello students, so here we are with the question 4th of the exercise 3.2 of the chapter pair of linear equations in two variables. So the question 4th is, which of the following pair of linear equations are consistent or inconsistent? If consistent, obtain the solution graphically. And the two linear equations have been provided in part A, B, C and D. So clearly, first step is to check whether or not the linear equations provided in the questions are consistent or inconsistent. And as we know the procedure to find the linear equations to be consistent or inconsistent, the first step is to find the ratio of the two linear equations, coefficients. So starting up with the A part, here the linear equations provided are x plus y is equals to 5. This is the first equation, and the second equation is 2x plus 2y is equals to 10. Simplifying this equation and taking the common factor, that is 2 common, or we can say 2 outside, in the bracket we will be left with x plus y, and 10 can be written as 2 into 5. So cancelling 2 from both the sides, we will be obtaining x plus y is equals to 5. Now, if we take a look over the statement 1 and 2, that is equation 1 and 2 are not different. They are the same statement or same linear equations only. As in both the linear equations, x plus y is equals to 5. Now, the next step is to find the ratio of these two linear equations. So, a1 over a2 comes out to be 1 by 1, b1 by b2 comes out to be 1 by 1. And C1 by C2 also comes out to be 1 by 1. That is A1 by A2 is equal to B1 by B2 is equal to C1 by C2. And if such a situation arises, then these two linear equations will be consistent. Which means that we are able to find the solution of these two linear equations. And what the next step is, if the equations prove out to be consistent? If consistent, obtain the solution graphically. What it means is that we need to represent now these two equations over the graph. So in order to represent the equations over the graph, we know that we need to draw the table between the two variables, that is x and y in this case. So our first step is to draw the table is to let the value of x. If we suppose the value of the x to be, say, 2, and if we put the value of the 2 in the first statement, the value of the y comes out to be 3, right? And if we suppose the value of the x to be 4, then the value of the y comes out to be 1, right? And as we know, the statement 1 and 2 are the same statement, which means that we no need to draw the different table in order to represent the second statement. The table drawn for the one statement is same as that for the second statement. So representing the points 2, 3 over the graph, which will be this point, and marking the point 4, 1, it is this point. So what the next step is to join these 2 points, that is we will draw a line which will be passing from these 2 points. So this will be the line which will be obtained for these two linear equations. As these two linear equations are same, means they will be overlapping over each other. That is, every point which will lie over the equation 1 will be the point of equation 2 as well. So we can take infinite number of values of x, then we can find the value of the y by putting those values of x in equation first, and those points over the graph will be the point which can be obtained from second equation as well. So this is the graphical representation of A part. Now coming to the B part, here the equations provided are x minus y is equals to 8 and 3x minus 3y is equals to 16. So these are the two equations. Our first step is to find whether or not these two equations are consistent. So we will find the ratios of the coefficients of x, y and the constant. So a1 over a2 comes out to be 1 by 3, b1 by b2 comes out to be 1 by 3, and c1 by c2 comes out to be 8 by 16. Simplifying them, that is 1 by 3, 1 by 3 and 1 by 2. As a1 by a2 is equal to b1 by b2, but b1 by b2, or we can say a1 by a2 is not equal to c1 by c2, so this is the condition for the lines to be parallel, which means that the lines which will represent these two equations will be parallel to each other. And if the lines are parallel to each other, we can't obtain any solution to these equations, which means that these equations are inconsistent. Right. Now coming to the C part of this question, here in this C part, the two equations being provided are 2x plus y minus 6 is equals to 0, and the second equation is 4x minus 2y minus 4 is equals to 0. Simplifying it and taking the highest factor common from the left hand side, we will be left with 2x minus y minus 2 is equals to 0. So this will be the second linear equation. And now the next step is to find the ratios. So 2 by 2 comes out to be 1, 1 by minus 1 comes out to be minus 1, and as from here a1 by a2 is not equal to b1 by b2, so this is the condition for the linear equations to be consistent. That is, the lines which represent these linear equations will be intersecting lines, as we know from the situations where we have proved the lines to be intersecting in previous question. So the next step is, as we have proved these linear equations to be consistent, we need to obtain the solution over the graph. So for the graph, we will draw the tables for the linear equation 1 and 2 separately. So drawing the table for the first linear equation, we will see if we let the value of x to be 3, the value of the y comes out to be 0. And if we suppose the value of the x to be 0, then putting this value of x in equation first, the value of the y comes out to be 6. Means 2 points which have been obtained from the table are 3, 0 and 0, 6. Now coming to the second equation, so in order to represent the second equation over the graph, we need to draw the table over the values x and y for this equation also. So if we let the value of the x to be 1, then the value of the y comes out to be 0 by putting this value of x in first second equation. And if the value of the x is assumed to be 0, then y comes out to be minus 2 by putting this value of x in second equation. So from this table, we to obtain 2 points that are 1, 0 and 0, minus 2. Okay. Now in order to represent these two tables over the graph, we will mark the 2 points from the first table, that is 3, 0, that is this point, and 0, 6, which is this point. Now we will be drawing the line which will be passing from these two points, that is this line, right? So now the next step is to mark the points obtained from second table. So the 2 points obtained from the second table are 1, 0, which is this point, and the second point is 0, minus 2, 0, minus 2, which is this point. Now again we will be drawing the line which will be passing through these 2 points. Okay, which means this purple line is the line for the equation first, and the orange line is the line which will be representing the linear equation second, right? And as it is clear from the graphical representation of these two linear equations that these 2 points intersect each other at point 2, 2. Right? That is 2, 2 is the intersecting point of these two linear equations. Now we will verify whether or not 2, 2 is the intersecting point. Now put the value of 2, 2 in first equation. If we put the value of 2 and 2 for the values x and y in first equation, then the answer comes out to be 0, which means that it satisfies the first equation. Now again put the value 2, 2 in second equation. Again the right hand side comes out to be equal to 0, which means that this point 2, 2 satisfies the second equation as well. So 2, 2 is intersecting point, which is pretty obvious from the graph. Okay, now come to the D part. In the D part, the equations provided are 2x minus 2y minus 2 is equals to 0. Simplifying them, it will be x minus y minus 1 is equals to 0. So this is the first equation. Now coming to the second equation, that is 4x minus 4y minus 5 is equals to 0. This will be the second equation. Now our first step is to find whether or not these two equations are consistent or inconsistent. In order to find the equations whether to be consistent or inconsistent, we need to find the ratios of the coefficients of x, y and the ratio of the constant. So finding the ratio of the coefficients, the a1 by a2 comes out to be 1 by 4, b1 by b2 comes out to be 1 by 4 and c1 by c2 comes out to be 1 by 5. As a1 by a2 is equals to b1 by b2 but not equal to c1 by c2, so this is the condition for the lines to be parallel. And if the lines are parallel, then the equations being represented by those lines are pretty obvious to be inconsistent. Why? Because we are not able to find the solution for these two linear equations. That is, there will be no point that will be satisfying both the equation 1 as well as for the equation 2. So this was all about the question 4th of the exercise 3.2. I hope this question is clear to all of you.